Okay, some more homework 31. Here's number 56. These are definite integrals, so we just can keep them in U and evaluate if we so desire. So let's take a look at this first one. This is going to be the integral from -1 to 1 5r all over 4 plus r squared dr. So we'll write this as an exponent up on top. So we'll write this as the integral from -1 to 1 of 4 plus r squared to the -2, and I'll put the 5r out in the back over here, times 5r dr. So I'll try to set up something like u to the n du. So we'll let u equal 4 plus r squared. But we've got to change our variables over here. So this is going to be the integral. And when we square -1, we get 1. So 4 plus 1 is 5. And then when we square 1, we get that. So this looks like this is going to be 0 because we're going to integrate from 5 to 5. So we can just go ahead and say 0. We can carry it through and just for completeness anyway. So you see what you would normally do. So we would write this as u to the -2 times 5r dr. Okay. Oh, I'm sorry, dr. This should be 5r dr, pardon me. And then I'll find out what the dr is, so I'll let du dr equal 2r dr. So those cancel, so we end up with du equals 2r dr. So I'll substitute that in. Well, first of all, get r dr equals du over 2. And I'll make that substitution. So I've got the integral from 5 to 5 u to the -2 times 5 over times du over 2. And then you can actually bring that out so we have it all set up. 5 over 2 times the integral from 5 to 5 of u to the -2 du. And I think by now we can pretty much put this one to bed. 0, because we don't have to carry it out because that's going to be 0. So it's kind of funny that they have you do all that work. Okay, so that's 56. Let's take a look at 58. And again, we've got the integral from -pi to pi. Okay. And this is going to be the cosine of x all over the square root of 4 plus 3 sine of x on the radical dx. This looks pretty interesting. So we're going to have to put this up top so we get an exponential form, because we know the derivative of the sines and cosines, so it's going to be probably some kind of u to the n du. So we're going to have the integral from -pi to pi, and I'll write this as 4 plus 3 sine of x. And since this was 1/2 power, it's going to be -1/2 times the cosine of x dx. And then it looks like this is going to be my u to the n of my du stuff over here. So what I'll do is I'll let u okay, so we'll let u equal 4 plus 3 sine of x. Okay, so we'll write this as the integral. And this is going to be u to the -1/2 times the cosine of x dx, but again, we've got to change our limits, put them in terms of u. So 4 plus, well, the sine of negative pi is 0, so that's just going to be 4 plus 0, which is 4. And again, the sine of pi is 0, so it's going to be another 4. So we're kind of like in number 56. But it's kind of nice to finish it up here, just in case it wasn't, so you know how to do it, because this is a nice problem. Okay, so du dx equals 3 cosine of x. The derivative of sine is cosine. That's dx dx. So that's 1. We put this other dx over here. So we have du equals 3 cosine x dx. I've almost got a match. I just need to get rid of the 3. So I get the cosine of x dx equals du over 3. I make that substitution. So I've got the integral from 4 to 4 of u to the negative 1/2. And instead of writing cosine x dx, we write du over 3. And we bring that out as 1/3. It's up here, sorry about that. So 1/3 the integral from 4 to 4 of u to the negative 1/2 du. And then we'd be normally ready to integrate this, add 1 and divide by that, and then evaluate that using the fundamental theorem of calculus, f of b minus f of a, capital F of b minus capital F of a. Sorry about that. But from 4 to 4, we know that that's 0, so it's all kind of academic. Okay? Alrighty, so we'll do some more. Hope that helps, and good luck.